All right, everybody, this is Mr. Enyart, and this is 6th grade math, lesson 19 in module 1 for Eureka Math. And we're going to use this question, question 3, on the practice to figure out how to use word problems in order to find rates from equations and graphs. And after we figure out how to find these rates, how do we use those rates? What does that information do for me? Why does it matter? How do I apply it to my life? How do I apply it to a real-world problem? And another thing I want to look at when we're dealing with real-world problems is what are some strategies I can use to help me better understand what's going on. How can I better use my common sense and logic based on these words? What do they say? What are some strategies I can use to truly understand what's happening and how to solve it? So I want you to think about these goals and what strategies we're going to do I will be talking about, but I'd like you to start, obviously, the first one is to read the problem carefully. Go ahead and take as much time as you need, pause the video and read the problem carefully. Okay, so now you've had time to read the story, and I want to go right into one of the first strategies we're going to use, which is to visualize. To visualize means to create a movie or picture in your head based on the words. So many of you probably know what cup stacking is, so maybe you can remember a time and recall and connect to an experience you have with cup stacking, what it looks like, what it sounds like, if you've ever participated in it, what it feels like, and how it works. Which leads us to our next thinking strategy, making connections. To make a connection, you have to be able to take new experiences and blend them with past experiences, whether a movie you saw, a book you read, or an actual physical experience you took place in. And the other two I think are really important here, and there's tons more, are to observe and describe what you see. These mean not only do you look carefully, but you also should be wording it out, writing it out or rewording it in your own words that make sense to you, and then reasoning with the evidence that's there. Asking questions like why? Why does it say that? Where did it get this number from? What does this T and this C mean? Where did these dots come from? What do these numbers represent? These are all ways that we reason with the evidence and make sure that we understand what we're doing and why we're doing it. Okay, so we're going to start working. I'm going to use Claire's information and do all her math in blue. And I'm going to do Kate's information and all her work in green. Feel free to pause the video at any point in time to work ahead and then compare what we're going to do. Question A asks, at what rate does each girl stack her cups during the practice sessions? So from this graph and this equation, I need to figure out Claire and Kate's rate of cup stacking. So I'd like to give you some evidence that you've already learned in previous lessons in Eureka Math. A hint is to find a rate from a ratio. We can simply divide the numbers to get a unit down to 1. So for example, if my ratio was 5 to 1, then I already have my rate. My rate would equal 5 of whatever this unit is to whatever this unit is, because that is per 1. But if my ratio was something along the lines of 15 to 3, I don't have a unit down to 1. But if I divide 15 and 3, the 3 becomes a 1 because I'm dividing it by 3 and making an equivalent ratio. And 15 divided by 3 is 5. So again, my rate becomes 5 of whatever this label is to whatever this label is, because I'm theoretically making an equivalent ratio down to 1, and this would be divided by 3, and this would be divided by 3 as well to move from the top number to the bottom number. Feel free to pause if needed. So So let's look carefully here at Claire's information, and this is seconds versus stacked cups. I want to make sure I read my graph. These numbers are representatives of the number of seconds she's stacking, and these numbers are representative of the number of stacked cups. So I can see here 0 to 0 really means nothing to me, but in 1 second she makes 5 cups stacked. In 2 seconds she'll stack 10 cups, 3 and 15, 4 and 20, so on and so forth. Now the good news is I don't have to do any dividing in this graph. The graph went ahead and showed me what my single unit is. If I have 1 second, then I am going to stack, or she is going to stack, 5 cups. Now I can write that ratio 5 to 1, and 5 to 1 would be cups stacked to seconds that I'm stacking, which means if I did 5 divided by 1, I get 5. And so it makes sense that if I have 1 second, which is my per, for every, my single unit in the rate, I'm stacking 5 cups, that my rate equals 5 cups per second. And that would be the rate for Claire. So now I want you to go back and pause the video and see if you can figure out how I found that information. If you already know and you were able to make that connection and you were able to reason with that evidence and everything I did makes perfect sense, then move on. But if you're unsure, this is a great time to rewatch it, work ahead, and see if you can figure out what a rate is, and that you can make a rate from a graph, that you can do that in real-world problems, which is what we're working with here, and that you're able to use these thinking strategies. So now I want to look at Kate, and you can see her information is given here in an equation. All right, now an equation is a little different than a graph or a table. However, it's actually what I think easier to find the rate, because it actually tells you right there in the equation you are looking at the rate. And now, just like Claire, the t, which is right here, represents the amount of time in seconds, okay? And time in seconds is going to be part of that ratio and rate. The c, which is the answer, or the final answer when you take 4 and you multiply it by seconds, represents the number of stacked cups. So just like Claire, Kate's rate will be listed in cups per second. Now the easiest way for me to think about this is that cups equals 4 times the amount of seconds. And if I'm trying to find per second, that means my second has to be a 1. So if I plug a 1 into it, cups would equal 4 times 1. And I'm going to do this every time I see an equation like this. I'm always going to plug a 1 in for the number that's being multiplied right here by the constant variable of 4. It's always 4 times. This is what changes. This is the changing variable. This is also another variable that will change. The 4 is constant, okay? So clearly 4 times 1 is 4, and therefore C equals 4, which means since C is what I'm going to be putting here in my rate is 4 cups per second for Kate. And now you can see that I have answered question A. I have their rates. I'm going to rewrite that here. And now that I've done that, I'm going to move to question B. So let's take this and read it. Kate notices that she is not stacking her cups fast enough. Isn't that always the problem? What would Kate's equation look like if she wanted to stack cups faster than Claire? So her rate has to be a higher rate than Claire's, and right now Claire's is 5, hers is only 4, so we need this to be above 5. So let's go ahead and start by writing Claire's equation. Claire's equation would be cups stacked equals 5 times the number of seconds, where C represents the number of cups stacked, and T represents the time in seconds. Now, Kate's was already given to us earlier in the problem, but it was 4T. Let's look for a second and see the relationship between the equation and the rates. Look at the green equation, look at the green rate. Look at the blue equation, look at the blue rate. What do you notice? So I'm sure you noticed that this variable means the actual rate. We just simply took the 4 to 4, and because the time seconds would be 1, and if I do 4 times 1, I'd get 4. If I did 5 times 1, I'd get 5. So this, in this equation, is my rate. So I want to write an equation that has a rate faster than 5 cups per second. So for Kate, my new rate would have to be, it's a weird N, we're going to say that's an N, my new rate would have to be cups equals 6T or higher. I could do 7T, I could do 8T, I could do 9T, but it has to be at least 6T. Now, if I wanted to get really crazy, I could even do something like C equals 5.5 T. However, this doesn't really apply to this question because you can't really stack half of a cup. It has to be whole cups. So this doesn't really work when it's cups, but if it was, meters, you could go a half a meter, something like that. So in this situation, our best answer is going to be using the 6T because that is bigger than 5T. And that would create a rate of 6 cups per second. Okay, so give yourself a big round of applause if you got through that. You took your time, you were observing, visualizing, making connections, reasoning with evidence, using thinking strategies. But the question is, always going back to this, can you find rates from equations, graphs, and tables? And how do rates help you in real-world problems? It helped Kate by making her realize she needed to practice more. It would have helped the judges know that Claire at this point is doing more, and she would win. So how could it affect you?